Hey everybody, Justin Worden at SMTAI International. You're watching What's New in Electronics. My guest today is Dan Migely of Impossible Objects. Man, how are you?
Good, Justin. Great to see you. How you doing?
Good, man. Hey, I'm doing great. Now, I've done this interview with you before, and I realized I said your name wrong. I said Impossible Projects, but that's kind of comical, right?
It fits the bill. You know, one of the unique things about our name is it draws attention, without question, but customers tend to bring impossible objects, they're impossible projects.
There you go.
Which, we love that. If we can solve that type of challenge for them, we're doing the right things.
Well, and I imagine the reason they're impossible is you're trying to fix something that they don't know how to fix on their own, right?
Absolutely.
So let's back up. I got so much I want to talk to you about, but let's introduce Impossible Objects. What are you guys actually doing?
So we're a 3D printer manufacturer. So we manufacture our own 3D printers. They're called CBAM, Composite-Based Additive Manufacturing. And we entered into this market, sometimes you're better lucky than good. I mean, people found us and uncovered that we have a material set that's perfectly appropriate and blows the material characteristics out of the water for this segment. And it's a perfect use case for our technology. Material, ease of design, iteration, freedom of design. It just checks all the boxes in this particular segment.
Well, and the unique thing about Impossible Objects, and the reason I think they bring you their Impossible Projects, is because you guys have the engineering and the skill set on staff to take these impossible projects and make them very possible. Now, that's just a bunch of words I just said there, but why don't you elaborate on that?
Yeah, it's true. You know, when we came into the market, it was a little bit of a me too. Vis-a-vis the traditional ways they're getting tooling, jigs, fixtures, pallets, things like that today. It's, can we do what their traditional suppliers have been doing? Sure we can. Further exploration and further with as our engineering and design capacities improved, we are solving problems that they weren't able to solve prior. And it's such a phenomenal difference in being at this show a year ago. 3D printing oftentimes is theoretical, right? We think it'll do this well. We'd like to see it do this. And we were in that same boat a year ago. We didn't know. Now after I'm here a year later, I'm seeing folks that I see all over, customers that are ours. We're part of the community. People coming up to our table saying, oh, that's my solution. Like we're truly creating solutions and being part of this community.
Well, it's not only that you're making the solution possible, you're doing it fast.
Yeah, absolutely. If you look at 3D printing has always been thought of as rapid prototyping, and in which it does an incredible job with. But I don't have setup. I don't have programming. I don't have, we play a game of Tetris where we look at design files, see if we can fit them in our build block and have the ability to flip that switch. I mean, we absolutely now, if you look at barriers for 3D printing, it's been material sets. We've got phenomenal material sets, certainly for this segment. Speed, and we'll talk on that. We've really blown away the speed barrier. And ensuring the structural integrity of those parts, no matter how quickly you produce them. And we've got all three of those bases covered. And we're the speed paradigm, we're blown away.
Well, you and I have spoke on this quite a bit,
Yeah.
so let's go back. And when you first came to me, I said, can it handle the process? And what I meant by that is, when you're building whatever you're building in the electronics industry, it goes through a lot of volatile, harsh environments. Yeah. So I said, before you come to me, and before I recommend you, I need to know that it can handle. What have you guys done to get those answers?
Well, fortunately, we've partnered with some great companies to do some of that testing. We've worked with Kaizen. They've done a great job actually taking material sets and coupons of ours and putting it through some of their more caustic chemistries with phenomenal results, which PEEK is an incredible polymer. I mean, it's 5 out of a 5 scale in chemical and heat resistance, but it's still been proving out that case. And real world experience, people who've gone through thousands and thousands of cycles of flux and solder and cleaning solutions, and to see a slight coloration change, but no change to mechanical properties has been phenomenal to see.
Well, those are the two main points, chemical and heat. And if you can handle those two parts, you can pretty much do whatever you want. Now, let's go back to the speed, because I know you're dangling that carrot on me, and I want to know, what is fast?
Our process today is fast. I mean, I can print, say, a 15 by 12 inch pallet in an hour today, a little over an hour. Now for carbon fiber PEEK, that's extremely fast. At Rapid last year in May, which is the additive manufacturing trade show, we released our CBAM 25 machine, which we're printing parts off today. That same pallet that takes about an hour, 10 minutes today will take 3 minutes. So it's not X% faster, it's orders of magnitude faster. Now, I brought a little prop because this, I can't help but show this as it relates to speed. Just a simple little bell crank here. The fastest technologies in additive today print about 170 of these in 8 hours. That's the fastest technology out there. We will print 3,000.
In 8 hours?
In 8 hours. It's the equivalent of a not very fast me running down the back stretch of Indy versus Max Verstappen's F1 car. I mean, to really understand that.
Well, yeah, and right now, with the industry the way it is, I mean, it's growing at an all-time rate. Not just Impossible Objects, you guys are doing great, and a lot of the other companies here exhibiting, but the industry as a whole with AI, and I've said it all day long, AI, space, EV, whatever you want to do. Or even COVID, bringing things more in-house. These customers of yours and the people coming out to you, they're not always just looking for a solution, they're looking for a solution right now.
Right.
And we need 1,000 of them.
That's right. We have the ability to manage that and scale with them. People ask us all the time, what's your ideal quantity? I said, 1. We're not afraid of that. We're not afraid of small volume. Now we have the capacity to do volumes that are off the charts. So it's really an exciting time. The material set is phenomenal. The bulk of what we print is carbon fiber PEEK. And the first thing people do when they pick up a part of ours is they're floored by the weight. That's always the first response, like, wow, that's half of what I'm used to or so. Then the avalanche of questions come. Oh, how about your ESD properties? Oh, it's carbon fiber, it's conductive, we'll fit the bill there. Oh, okay. Heat deflection temperature, oh, you can withstand 300. The questions continue to come and we're able to check off all those boxes.
Yeah, and the thing is too, when you talk about weight, less stress on the machine.
You got it.
Less stress on the employee, because at some point there is some sort of manual handling process. So, which allows better speed. So not only speed on the side of you guys making the part, but speed on the production for them. Absolutely. And in the end, all we're doing, no matter what we're selling the customer, we're trying to save them money, a la make them money, right?
That's right.
So if they can speed up their process, they're making more money.
No question. Back to kind of the rapid prototyping aspect of it. The exciting stories for me are customers that we have helped earn very big business. They're selling who they are. They need a very, very quick solution. And they have a customer coming in and say, hey, listen, we have to show them our process and we need the tools to do it. How quickly can you do this for us? And they've had record months because of our ability to show their customer their ability to handle that project.
So let me ask you this. I mean, for someone that they're sitting there, they have a problem, they don't know what to do. What advice would you give them? They don't know how to design it. Here's what my part looks like. It's not working. What do they do?
Pick up the phone. Go to the website. It's www.impossible-objects.com. Gives a great overview of the material sets and the process. But when they get engaged with our applications engineering team, we're going to collaborate and create a solution. And that's what's exciting. That's where earlier I talked about a Me Too technology to start. What's really exciting about it is when we're having those conversations and creating custom solutions for that particular customer, that particular project. And that's where we shine. Let's collaborate. Let's use our engineering capabilities to come up with a solution that works for that customer.
So what I think I'm hearing is it might not be an impossible project.
Right.
They just don't necessarily know what they're asking for, but your team will help them.
Absolutely. And there's no one size fits all for 3D printing. That's a reality. But as long as we're wildly transparent and communicative about the deliverables, they're going to know they have a solution at hand. And that's the exciting part about this. When we start unlocking the process engineer's creativity is when the light bulb goes off and this really impacts their business in a new way.
Well, man, I think you explained it perfectly. Give us that website one more time.
www.impossible-objects.com.
All right, Dan, it's always a pleasure. Thank you so much.
Justin, always a pleasure. Thanks so much for the time.